question 4. So for part A, using calculus, find the exact coordinates of the turning points. So we have to differentiate the function. So we use the product rule, u dv dx plus v du dx, where u equals 25x squared and v equals e to the power of 2x. So du dx, when we differentiate this, is 50x. dv dx, when we differentiate this, is 2 lots of e to the 2x. Substituting these four into this, we get this, which we can factorize to this. Now at a turning point, the differential equals 0, so we solve this equaling 0. This is 0 when x is 0, this is 0 when x is minus 1. Now to find out our y values, we substitute our x values back into the function. When x is 0, this first term is 0 because 0 squared is 0, so 0 minus 16 is minus 16. When x is minus 1, well, minus 1 squared is 1 lot of 25, so we've got 25 lots of e to the minus 2 minus 16. So that's our y value exactly. Now for part B, we've got to show that the function equaling 0 can be written as this, not the differential, the function. So we go back to our function and set it equal to 0. Add 16 to both sides, divide both sides by 25, divide both sides by e to the minus 2x, gives us x squared equaling this. So square root both sides and we get x equaling plus or minus 4/5 e to the minus x as required. Now for part C, very straightforward, these iteration formula questions. We've got to calculate the values of x1, x2, x3 given that x0 is 0.5. So you start off by substituting 0.5 in to work out what x1 is. I get this. Take this x1 and replace that in the formula to work out what x2 is, and then use the x2 value in the formula to work out what x3 is, giving us these three values. Now for part D, we're being asked to give an accurate estimate to 2 decimal places for alpha. Well, we've just got it closer and closer to the true value using the iteration formula, so 0.489 is very close, so to 2 decimal places 0.49. Now to justify this, you take the upper and lower bound of this number, 0.485 and 0.495, substitute that into the function, and you get one value being a negative, one value being a positive. You can then conclude sign change between the two bounds, so alpha equaling 0.49 is accurate to 2 decimal places.